Okay, so up to this point, we've looked at very basic rules with exponents up to the end of 4.2. And 4.3 is just building off the exponent laws again. If you look at the starting page, page 70, basically all they're saying is that they define those laws again, and then you go through and you do some more work with them. So the difference between 7.2 and 7.3 is you're working more in 7.3 with rational or fractions, rational expressions of fractions, okay? So write each product or quotient as a power with a single positive exponent. So in this case here, I have the bases are the same and I have two exponents. What do I do with the exponents? Add them. So I need to go 7 1/2 plus 3, right? And what does that equal? Say again?
7 to the power of 3.
Okay, now because we're using this as an exponent, we're not going to use it as a mixed fraction. So we want to use it as a improper fraction.
7 to the power of 7.
Very good. Very good. Common denominator here is 2. So 7 over 2. Okay. Common denominator between 1/2 and 3 is 2. So what do I times this 1 by to get to 2? I times it by 2, so I do the top. Common denominator. Erica, did I lose you there? Okay, let's try this, America. Let's go 1/2 plus 3/4. How do I add those together?
Look. 5 over 4. Oh, that's how I do.
What do you get?
5 over 4.
5 over 4? That's what you think the answer is?
Yeah.
Okay, how are you doing that?
Like I put the 4 on the bottom, and like how many times I have to multiply the 2 to get 4? Like 2.
Yeah.
So 2 times 1 is 2 plus 3 is 5.
So you got a common denominator. So that's 2 over 4, are you right?
Uh-huh.
That's what you're talking about? Plus 3 over 4. Right? Which gives you 5 over 4. Okay, that's great so far. Good. So what's the difference with this?
Well, it's got it.
This is 3 over 1, right? Everybody following me? Okay, so what's the common denominator between 1 and 2?
2.
2, so I have to multiply this by 2 over 2, right? Which gives me 1/2 plus 6 over 3, sorry, 6 over 2. Right? Which is 7 over 2, which is exactly what I got there. Everybody following that? It's tough fraction work. Gotta know your fractions. You're going to go into this line with applied pre-calculus. There's a lot of fraction work as we go. So we start working with it more often. Okay, so far. Now, let's look at the other 3 examples, or 4 examples, sorry. So 4 examples so that we see what we're doing in each case. So I have 9, 1.25 over the 9 to 3/4. Okay. What do I do with the exponents here? Minus them. How do I do that? Say again, Roy, louder.
You change the 1.25 into 1 1/4.
1 1/4, which is Yeah. But remember, I don't want that. You're doing good. You're doing right. Yeah, it's good. Okay, so 1.25 is 1 1/4, correct? 1 1/4 is actually that. We agree? Here's a trick question. What is 9 to the 1/2 equal? No. 9 to the exponent 1/2. What does it equal? What does an exponent of a half mean? If I rewrite it as an exponent to the 1/2, what have I taken it away from? Like, what have I done different? Where does the exponent 1/2 come from? Is my question. Well, what have we been doing up to this point? What did you start with? Yeah? Yes, it is. America. Isn't 9 to the 1/2 the same as this?
Oh, I get what you're saying. I get it now. Yeah.
Okay, it means the same thing, does it not? So what's the actual solution to this? Your final answer in this question is 3. Square root of 9 is 3. Okay? Does everybody follow what I did there? Now, we started this 2 days ago, where I started going from here to there, right? And then I did the cubic to a third as an exponent, right? We did that the other day, okay? So we still have things we want to do. Now, we could have done this question instead of doing it in fraction form. I could have done this.
Yeah, that's what yeah.
Okay, that's okay too. That's perfectly all right. So what's 1 1/4 subtract 0.75? That, which would be this, which would be this, which would be, right? That's okay. Whichever one you want to work with. All right? Getting this down, Morgan. Okay, let's look at this next one. Any questions about this? Look, this is, I told you this at the start of the week. This is going to be the hardest unit you do this year. So if you're not asking questions, that means that you know what you're doing. And if you don't know what you're doing, then you had better start asking some questions, because we keep going otherwise. Okay, and like I said, this is not an easy unit. You have to ask for help if you don't understand something. Right from the very basics. And if you don't get it from 4.1, it's a tough unit. All right, so I have this 16x to the 4th. No, not to the 4th. 6. To the 1/4. Okay. All right. When I have an exponent to an exponent, what do I do with it? I multiply them. What's the exponent on 16 right now?
6. No, 1/4.
No? Is it not 16 to the power of 1? Yes or no? Yeah. Now it's important to me, because what happens with you guys is you forget that that's actually there. Now when I go an exponent to an exponent and I distribute it through the brackets, I have to know that 16 to the power of 1, that 1 has to now times by a quarter as well. So this should read as this: 16 to the 1/4 x to the 6/4. 6 times a quarter. 6 times 1 is 6. 6 divided by 4. Okay? Now, can 16 be broken down? Gary asked me this the other day about prime factorization. What does 16 break down to?
4.
What do you mean 4?
What do you mean by break down? The square root of 16 is 4.
Square, yeah, but I don't want square root. I
And
don't have a square root.
1/4 of 16 is 4. No.
Okay, no, let's do this a different way. What can 4 be broken down to?
2.
Times
8.
4 is 2 times 2, no? I'm just saying. Okay, so, alright, give me the factors of 16. What do I multiply to get 16? 4 times 4. Perfect. 2 times 8, 4 times 4, right? Let's look at 4 times 4 for a second. What do I multiply to get 4 times 4? Or just 4, sorry. 2 times 2, no? So, when we're talking about prime factorization, so this is completely different. This goes to this, right? 4 times 4? Yeah? No? Yeah? 2 to the power of what gives me 16? How many 2's do I have there?
4.
2 to the power of 4? 16. So I can write this as I just reduced 6/4 for the record, right? Now what do I do when I have an exponent to an exponent? Pardon me? Multiply it. What's 4 times a quarter? What is it? What's 4 times a quarter? Sure. What's 4 times 1?
4.
Divided by 4? So it's 4 times 1/4, 1?
Yeah.
Whoa. We got some work to do, people. There's your solution for this. Let's start getting back. I don't know what you guys have been doing all week. This is stuff that you should have been doing all week. Alright, if I ask you what the, break this down for me. What is it? 8 times 4. Garrett, you asked me this the other day about prime factorization. And what did I say? You gotta break it down until you get to the point where nothing can be multiplied by anything but itself in 1, right? That's a prime number. So we gotta break this down. Are 8 or 4 prime numbers? No, because what goes into them?
2.
Okay, so what is this one? What do I multiply to get to 8?
2 times 4.
2 times 4. How about here?
2 times 2.
Okay, am I done? No, because this can break down, no?
2 times 2.
Alright, 32 then can be rewritten as 2 to the power of 5. That's called prime factorization. You should have been doing that in 4.1. I asked you to do it a few times. Okay? So there's the first issue we have. We need to now, we already did the adding of fractions. For some reason we don't seem to be able to multiply fractions very well. What is 2 times a quarter?
0.5.
That's not a fraction, is it?
1/2.
Right? It's 1/2. Just asked you that less than a minute ago, right? We couldn't do it. How do I multiply this? How do you actually multiply it? What are the steps in multiplying a fraction?
We put it over 1.
1 over 1 and then rid of columns.
Okay, you want to put it over 1? Sure. And then what?
Right across, then it'll be 4 over 4, which is 1.
Okay, sure. When you multiply fractions, you multiply across the top and everything across the bottom. You agree with me? All right. What happens when I have a number that's on top that can be divided by a number that's on the bottom?
Reduce it.
Sure, why not, right? Isn't that what I did with this?
4.
What did I get for that?
3 over 2.
For 3 over 2, right? Correct? Because 2 goes into both those values. So that's reducing a fraction, agreed? I wouldn't do this. 4 times a quarter. What am I left with? Okay? If I were to do a larger number, what's that equal? No, I don't need you to write down. Just multiply it the easy way. Without
3
reducing.
over 10.
What is it, America?
6 over 2.
6 over 20, right? Times across the top, what do you get? 6. Times across the bottom, what do you get? That wasn't very tough, right? Okay, that's normal. But I also know that 2 goes into 4 how many times? Twice. So what does it equal? 3 over 10. Okay? When doing fraction work, it's often easier just to do it up here by reducing things. Now you could have got 6 over 20 and then reduced it at that point. That's fine. But for me, I want to do it sooner, so then the math is easier. But whatever. Okay. Let's look at D. What's on the bottom?
3 3/4.
Thank you. Okay? How do you want to approach this? Well, that's up to you.
Change 0.25 into 3 and 1/4.
I would I'd put 0.25 and then put 0.75 as the bottom. Get rid of the. Yeah, that's just what I would do off the hop.
Okay? So, Rory wants to change it to a fraction, but you went 1 step too far. Daylene wants to change it to a decimal. Both are all right. But then at that point, what do you want to do next? By what?
Other 3 other spots. Like,
Okay. Both of them or one of them or what?
both of them, because there's something else.
That's right.
Oh, no. Because there's something else, did you subtract numbers?
Okay, well that's the other question I had. That's what I was trying to get at. All right, so here's what Rory's doing. She's doing a good job of working through this right now. First thing she said was this. And that's fine. Did 3. Then she said, well, I would multiply by the exponent on the outside. So you got your exponent to your exponent, multiply it. So I get 3 to the power of 3/4. And then I get 3 to the power of 9/4. Okay? Remember that 3 is for both the top and the bottom. So I have that, right?
I would have subtracted.
Alright, I'm gonna work with her, and then you and I are gonna do it next, because she also stated that too. Okay? So yeah. So now what do I have? What do I do?
Subtract them.
And what do you get? 3 and
6, 4,
6 over 4.
so 3 over.
3 and 3 over 2, right? Okay? So now, Rory then said, well, no, maybe I would have subtracted them first. Which is fine as well. Okay? 1/4, subtract 3/4.
3 and negative 2 over 4.
Okay? So 3 to the negative 1/2. Agreed?
So then you would just go 3 times negative 1, and you get 3 over negative 3 over 2.
That same thing?
Yeah, and then you.
Hold on.
No, it's not.
Is that the same thing?
No,
No,
it's
no,
negative.
It's not.
What is?
The exponent.
Okay. So which one's right and which one's wrong?
They're not wrong, you just have to put it over each one.
Yeah,
Because you have a
it's
negative
not gonna go
exponent.
up, do you not? So it would be like 1 over 3 to the power of 3/2.
Is that the same thing as this?
Yeah.
Is it?
Yeah. No? Am I wrong? I don't know.
Well, wouldn't it be the same because?
Is 1/4 and 4 the same thing?
1/4 and 4,
Are they the same?
like 1/4 and 4 is 1.
No, 1/4 and 4, are they the same two numbers?
Well, they could be because
Are they the same?
No, I don't know.
Is 1/4
No.
and 4 the same thing?
No.
So then how can 1 over 3 to the 3 over 2 be the same as 3 to the 3 over 2?
No.
We made an error on the right side. Somebody pick up the error for me, please.
You have to do the red mouse.
No. No. We have one glaring error there. What is it? What did we do with the exponents?
Did we choose?
What did we do with the exponents? How did I go from here to there?
You subtracted them, but
What did I do?
you subtracted them, but it's wrong because it's not 9 take away 3, it's 3 take away 9. So then it should be negative 6 over 4, and then you get 3, and then you get negative 3, and then
Now
you
are
get
those
over
two the
1.
same thing?
Yeah.
Yes, they are. Okay? That's a perfect example of how errors get made in this unit. We didn't do it very different, but we got a different answer because we made an error. This is not easy. Say that, I stress that enough. It's not easy. Right? So we understand what happened here. So now, let's take another run at this and let's do it Dalen's way. So this is 0.25, right?
Mhm.
And then this would be 0.75 down here. Is that correct, Dalen?
Yeah.
To the power of 3. Then you want me to subtract them first?
Yeah, so 0.25 subtract 0.75 is negative 0.5.
Like that.
Yeah.
And now what? So what do I get here?
Negative 0.5 times
For me?
3.
Yeah.
It's like negative 3. Yeah.
Okay. Right? Wrong? Same? Different? What is it? You got it right? Is that the same as what we got on the other page? Okay. What do you think? that the same as this?
Yeah.
It is? Is that what we got on the last page?
No, we got over one. Yeah.
We put it over 1 to make it positive, yes.
Yeah.
But we got the same thing. Okay, both methods work. You choose the one that you like best. Okay? Alright? Okay. Shut your book. Take out a piece of paper. What do you want a calculator for? We're not using calculators.
I can feel better.
It's great, you're not using it. Alright, has everybody got a piece of paper out in front of them? Garrett? Yeah? You ready to go? You done visiting? A to the 6th. Use the exponent laws to simplify each expression. Where possible, compute to numerical values. Who doesn't know where to start this question? Okay? If you had your exponent laws beside you, would that help you? You don't think so? Okay? Because I think that would help you. Alright? When I have the same base and I'm multiplying, what do I do with the exponents? What's the exponent law say? Really? Do you know?
I don't know them by my brain, I know them by the book.
Okay. Alright, open your book then to page 70. Page 70. You two open your book. Who else is struggling with this? Put it on page 70 in your book if you need the exponent laws. But I don't want you looking at any of the material. What does it say? What's the first exponent law? What do you do with the exponents here? Add them. So that is a to the 6 plus 3 over 2. Is that what the exponent law says?
Product of powers. I think that's the one.
Okay. So to add these, what do you get?
15 over 2.
All right. How many of you got that right? Oh, man. Okay. Okay, try that one now.
Oh, yeah, you just wait. You just 55. Still right.
Again, I ask, what do I do with the exponents? Add them. What do I need to do when I'm adding fractions?
Common denominator.
What's the common denominator between 3 and 2? 6.
So just
So 2 over 6 plus 3 over 6, does that look right? Yeah?
Mm-hmm.
Y equals?
5/6.
How many of you got that right? How many of you got that right but didn't get the first one right? Good. So there's improvement. That's what I'm wanting to see. Who's not getting either one of those right? What's the problem? Is it the fractions or is it the exponent laws? So we need some fraction work. It's the laws. Okay, well it's the same law here, right? So you're gonna know what to do on the next one? Okay, let's check it out then. Here we go.
do you have extra fraction work? Because I don't think that would hurt if I did some extras.
Okay. What do I do with the exponents here? Do you want to change it to a fraction? Okay, well what's 4/10 as a fraction? 4 over 10. Okay, and I'm going to add it to 1/2. Agreed? Okay?
So that is 5/12.
Gives you what?
5/12.
5/12. Do we agree? No? Alright, so this is what my question to you is the fraction work. What do you have to have in order to add two fractions together? What's your common denominator here? 10. So how do I change 1/2 so that I get 10?
Times 5 and then times 5.
Okay, so that gives me 5/10. Do you agree with me? Yeah? So now, what does x equal?
9 over 10. You wouldn't believe me, but I have that written down.
That's fine. Okay, so you did get that? Okay. How many got that one right? How many of you? Fractions? All right?
Yeah.
You? Yeah? Did anybody change it to decimals? What'd you get?
0.9.
0.9? I may have done that as well. X to the 0.4 times x to the 0.5. Add them together, x to the 0.9.
Mr. Noonan, why are fractions more important than decimals? And when the decimal is so much simpler to do.
The reason being is when you're doing decimals that are finite or decimals that have ending, that are terminating decimals, it's easier. But if you have a fraction such as 1/3, okay,
Yeah.
and you want to change it, so let me show you, okay? What if I had done this? What if I had done that? Would
Sure.
changing 1/3 to a decimal make that an easier question?
Not really, because 1/3 is 0.33 repeating.
Exactly. So that's why. That's why we work with fractions more than we do decimals. Now, because you had 1/2 in this one, it worked real nice. I would have done the same thing there. But when you have a fraction that cannot be put into a finite number, meaning it's not a terminating one, like a repeating
Yeah,
decimal,
it's not repeating.
then it makes it a little more difficult to do the question. Now you're rounding, right?
Right.
Okay, so that's why. All right?
All right.
Now, I don't care. You use what you want. In this question here, I would have changed it to fractions because 1/3 isn't a good decimal to use. Okay?
Okay.
But any other ones that you think are good, easy, go ahead. I'm okay with that. All right?
All right.
Okay. It's a good question though. Why do we do that? All right. Okay. Let's keep going. All right, let's check this out. So I'm looking for a reduced value and a positive exponent. I want a reduced value and a positive exponent. So try that. All right. Billy, find your rule for your exponent to your exponent, or a power to a power. Right here. What do you do with the two exponents? Multiply. That's what that means. All right, what do I do with the two exponents? Multiply. What is negative 6 times 2/3? Don't use your calculators. Minus 12 over 3? I like it. I like it. Okay? What is minus 12 divided by 3? No? Does that not make sense? Right? And then, instead I wanted a positive exponent. So I put it under 1. How many of us got that right entirely? No. Okay? Not bad.
So when I want to make from a negative or positive one, I just have to put it under 1.
All right. How many of you had difficulty multiplying these two without a calculator? Okay? So again, multiply across the top. What's 6 times 2? What's 12 divided by 3? Okay? Calculator is not necessary for that question. That needs to be done. Now, I could have also done this. How many times does 3 go into 6? Twice. What am I left with? 2 times negative 2, which is negative 4. But that's sometimes confusing to people. So just go across, divide, reduce. It's your best bet. Okay? So I'm working you through some things because I want to see where we're at. Last one, and then I'm going to answer some questions from yesterday. Now remember, I told you this at the start of the week. There are certain values that you need to automatically recognize that are important, such as perfect squares, perfect cubes, right? So work through this question now. 81 to the 1/4 squared. Who thinks they have the answer?
81.5.
Okay. She said 81 to the 1/2. How many of us got that? Good. Awesome. Is that my final answer? What does that equal? 9. Who got 9? Good for you. Good for you. Okay, remember I was one of those ones I said you want to recognize, right? Now, there's a different way I could have approached this question. Watch. Watch. As soon as I saw 81, what do I know about 81? It's a perfect square. It's a perfect square, right? So I may have done this. Changed 81 to 9 squared. Changed 81 to 9 squared. Okay? Because it's a perfect square. Now, what you don't know is that it's also 3 to the power of 4. But I wouldn't change it to that. So now what do? What's 2 times 1/4? What's 1/2 times 2? 1. Okay, let's do this again. What's 2 times 2?
4.
What's 4 times 1/4? 1. Silly math, eh? Okay? Alright? How are we doing?
One question I have is, let's say it's like, what, your answer is 162 to the 1/4 for the 2. Or like, let's say it's different, so you don't get 1/2. What if you get like,
Okay, what if this, alright, let's do this right here. I got you. I got you. I know what you're trying to say. So what do I have? 81 to the 1/4?
no, I mean, what if you really?
What do you think the answer is here?
Oh yeah. It's 81 to the 0.75 for the 3/4.
Yeah, this one I did.
And you just leave it like that, Elijah.
You do?
There you go. There's your answer.
You don't have to.
Yeah.
No,
I think we got one.
No, I shouldn't say that. This is a unique one. Just 1 second here. It's a unique one. I actually should break this down. The only reason I break this down is because it can be broken down. I just finished saying this. 81 is actually 3 to the power of 4. So now I'm not there yet. We're not anywhere near this yet. But this is what should have happened. Now what do I do with the exponents? Okay, so what's 4 times 3? Divided by 4? 3. So that leaves me at 3 cubed. Why did you get that? Right? Well, what's 3 cubed? So 81 to the 3/4 is actually 27. So I should have gone all the way there. But your question was, what if this was an obscure number? What if this was 162 to the 3/4? Then leave it like that. Okay, if it can't be broken down, you leave it. But this one could be broken down. It was just a fluke. Okay, the way it worked. All right. Okay, I'm going to shut the camera off and I'm going to answer questions from 4.1 and 4.2.